Hey everyone, and welcome back. Today we are going to learn one of the most efficient problem solving techniques, the sliding window. This technique is perfect for problems with arrays and strings, where you need to find something in a continuous subset, like maximum sums, smallest lengths, or longest substrings. Let's dive in. Let's take this example. We are given an array of integers and a number k. We want to find the maximum sum of any continuous subarray of size k. The brute force method is about checking all the possible subarrays of size k. For example, we calculate the sum 2, 1, and 5, the first three elements, the first k-length subarray, and we find the sum is 8. Then moving to the second three elements and keep calculating the sums for all the subarrays with length of k, and so on. But this solution is inefficient. It requires a nested loop which has a time complexity of O of n multiplied by k. But now, with the sliding window technique, we avoid recalculating sums repeatedly. Instead, we calculate the sum of the first k elements, then slide the window one element at a time. So, without calculate the sum for each k elements, we just slide the window. We subtract the first element of the substring and add the new element to it. So now we remove the 2 and add the 1. So we have sum of 7, and so on. Also here we removed 1 and add the 3 to the sum without calculate the 5, 1, and 3 like the brute force technique. So we have a formula that the sum of I minus 1, the previous sum, add to it a of n, so the new element, and remove or subtract the previous element. So using the sliding window, we do not have to iterate twice over the subarray, so the time complexity is O of n. Let's take another example. We are given an array of positive integers and a number s. We want to find the length of the smallest continuous subarray whose sum is greater than or equal to s. So we want to return 0 if no such subarray exists. To solve this problem, we should shrink the window from the left to find the smallest valid subarray. Now, let's take 2. The sum is 2 and the length is 1. We just have one element. Is 2 more or equal 7? False. So let's take the second or the next element. Let's take 3. Now 2 and 3 equal 5 and we have two elements. 5 more or equal 7? No. So let's take the next one. 2, 3, 1. We have 6. 6 is still less than 7, so let's take the next element. 2. We have 2, 3, 1, and 2. The sum of this subarray is 8. 8 is more than 7, so let's remove 2. Now, 3, 1, and 2 equal 6. So 6 is less than 7. So let's take the next element. Okay, 3, 1, 2, and 4 equal 10. So is 10 equal or more than 7? It is more than 7. So we should remove the first element. Okay, after we remove the 3, let's calculate the sum. We have 1, 2, and 4. So the sum equals 7. 7 equals 7. So we should also remove the first element. Remove 1. Now we have two elements, 2 and 4. The sum of 2 and 4 is 6. 6 equal or more 7? Of course, no. So let's take the next element. Remove. We have 2, 4, and 3. We have sum of 9. 9 is more than 7. So we should remove the first one. Let's remove 2. Okay, we have 4 and 3 equal to 7. 7 equals 7. Okay, now we finish iterating over all the array. So let's look at the table we made. We have sums and lengths. So let's take all the sums that more or equal than 7, S. Okay, we have this one and this, and this. Okay, we want to look at the less at the smallest subarray, at the smallest length one. What is the smallest one of these? 4, 4, 3, 3, 2. There is 2. There is. If you look at the code, we are expanding and shrinking the process step by step. And the time complexity of our code is O of n because the start and the end iterate over the array just one in time. So guys, that's the sliding window technique. We explored fixed size and variable size windows and saw how it can optimize solutions for many problems. Try implementing this in your own and you will see how powerful it is. Let me know in the comments if this made sliding window easier for you and don't forget to like and subscribe for more tutorials. Thank you.